This is San Marcos, Texas. Over a century ago, the United States Fish Commission dug a well plunging 188 feet into the earth, right at the heart of the city. And when they did, water rushed to the surface at thousands of gallons a minute, flushing out dozens of undiscovered creatures from the depths below. These animals had never seen the surface, nor would they, because all of them were blind. Perhaps the strangest looking animal in this catch was a species dubbed Uricea rathbuni, now known as the Texas blind salamander. Upon discovery, herpetologist Leonhard Steinegger described them as such.
These animals, by want of external eyes and their white color, at once proclaimed themselves as cave dwellers. But their extraordinary proportions suggest unusual conditions of life, which alone can have produced such profound differences.
These unusual conditions are contained to a specific 26-mile stretch of caves in the Edwards Aquifer, an extensive underground layer of rocks. It's the only place in the world this species of salamander has ever been recorded. So how did these caves create the profound differences in these salamanders' appearance? In other words, how did they end up looking so weird? To answer this question, we have to go back in time, way back.
Take the dates with a grain of salt, but we think that this group split off from its most recent common ancestor probably around somewhere between 10 and 15 million years ago.
And geologists estimate that the aquifer had been hundreds of millions of years in the making. During the Jurassic period, some 200 million years ago, the area was occasionally covered in shallow oceans. But when the area was dry and exposed to air, the rocks were eroded by weather to make porous caverns. Eventually, a shallow basin of water and sediment covered the land. Then, that basin dried up. But rainfall continued to eat away at the earth, to create the deep fissures and caverns inside the aquifer. Scientists like Devitt think that as the climate became more arid, some salamanders crawled beneath the surface, seeking refuge in the cool and stable environment of the Edwards Aquifer. And over the course of millions of years, these salamanders adapted to the aquatic subterranean caves by evolving certain features, like blood-red gills outside of their body, while losing others, like their eyes. Living in complete darkness alongside prey that was also blind, the salamanders simply didn't need to see, and energy used for sight would only be wasted. Today, only 2 small black dots just under the skin remain as evidence of eyes past. Those dots likely only detect if it's light or dark out. This use it or lose it type of evolution also applies to their silvery white skin. Skin pigmentation usually protects animals from the sun's UV light, and serves as camouflage from predators. But both of those are non-issues for the blind salamanders, who don't have to worry about the sun or predators. These small, spindly salamanders are at the top of the food chain in this ecosystem, feeding on various crustaceans like shrimp. And even though they can go months without eating, when a potential snack does swim by, several features help them capture their prey. One is a special adaptation similar to the lateral line found in fish, which detects vibrations in the water. The salamander's sensory cells respond to changes in water movement and pressure, letting them know what direction and how fast their meal is moving. Another helpful feature is their large head, which fits 10 to 15% more teeth than surface salamanders. More teeth means a deadlier bite, which is crucial if you come by prey only a few times a year.
All of those things are characteristics that help you survive in a very, very challenging environment. So that's why they look the way that they do.
Fenolio is one of the lucky few who's seen these elusive salamanders up close. Last year, his team at the San Antonio Zoo bred Texas blind salamanders for the first time in a lab, and they've repeated their success 4 more times. They're aiming to protect the species from extinction, since the salamanders have been endangered since 1967. 2 main things threaten the Texas salamander's survival. The first is contamination from wastewater runoff. This is a big issue, because the Edwards Aquifer is a so-called karst aquifer, which means it's made of soluble rock like limestone. Any pollution on the surface can rapidly seep into and contaminate groundwater. Wastewater typically holds tons of nutrients, which fuels the growth of algae. When the algae decompose, this process sucks oxygen from the water, leaving less oxygen for our sensitive salamanders. The second threat is a loss of habitat. This happens when rainfall cannot adequately replenish the water that people take. And this threat is real. The aquifer serves several cities, including San Antonio, one of the fastest growing cities in the nation, and the largest city in the country that relies entirely on an aquifer for its water. So while being able to breed the salamanders is a good first step towards one day building up colonies, the animal may be confined to labs if they have no home to return to.
In areas where there's been, hundreds of feet of groundwater depletion, we've almost certainly already lost species to that. But we just don't know about it because we're still describing new species from the aquifer all the time.
Devitt's team is using new tools to suss out blind salamander populations, such as a method that analyzes water samples for traces of the animal's DNA. He and his collaborator recently discovered 4 new related species in the aquifer. For now, scientists say that these salamanders can hang in there as long as the only home they've ever known stays constant. But that's an increasing challenge as more people move to the area.